Perfect. Okay, so let me rephrase everything what I've said before. So welcome all. Thank you very much for joining me today. This is the second part of using Microsoft Graph API with OutSystems. Last time we talked about how to access Graph API resources using application permissions and acquiring an access token using an OAuth client credential flow. And this time we basically do the same, but we now acquire a token with user privileges, which is a little bit more complex. We need a user that is signing in to an application, and then hopefully he will get an access token from the identity provider. I got some feedback from the last webinar. So first of all, I increased my screen resolution. Some people were complaining that it was hard to follow, especially during the development part. Another feedback was that I should do much more live coding, which I will do. So I have not prepared too much for today. So we will build everything from scratch, which could end up in a total disaster. So bear with me in case something is not working right away. But I already wrote it in the description of the webinar that there is a danger of ad hoc troubleshooting what we are building. But let's start. Let's start with some theory first. We start off with a quick recap of part one. It is not necessary that you have watched the video, the recording from part one, because I will explain the necessary parts in this webinar again. Then we talk about that OAuth 2.0 or Authorization Code Flow. That is a standard which is required to acquire an access token for Microsoft Graph API under user permissions. Then what's the difference between signing into an application and linking an account? We will see in a bit what that is. And then, of course, what we need to build in our OutSystems application to get access to Graph API and use resources. Okay, quick recap. So last time, what we did is we registered our OutSystems application with Microsoft Entra or Azure App Registration, which was the previous name for it. And we gave our application the right to send emails. And doing that is sometimes critical. So permissions on application level grant the application by default lots of permissions, lots of rights. For example, granting an application the right to send an email automatically grants the application to send an email on behalf of every existing mailbox within the organization. You can strip that down by applying application policies, but in the end, application permissions are very powerful and should not be used in case if you only need permissions that are bound to a specific user. This is what it's all about today. So let's talk about how is acquiring a token working under user permissions. In part one, when using that client credentials flow, what we did is we just executed a post request to the so-called token endpoint of the Microsoft Identity Provider using a client ID and a client secret. We retrieved from the Azure App Registration, Entra App Registration portal. And in turn, we got a time-limited access token to do whatever we want to do. With Authorization Code Flow, it's a little bit different. So first of all, we need a user. So a user in front of a computer with a browser. and he wants now to open up our application. And what we then need to do is that we need to redirect that user to the Microsoft Identity Platform, to the so-called authorization URL of the Microsoft Identity Provider. And then the user logs on with username and password, maybe with some additional multi-factor authentication. And that is validated. So the user is authenticated with the Microsoft Identity Platform. And then the platform redirects the user back to the application, to a so-called redirect URI, which includes a code. And that code, together with a client secret and client ID, can then be exchanged for an access token. So we will see later when we build it how that works, but in the end, we need a browser for the authorization code flow. The browser redirects to the identity platform. The identity platform, after successful authentication, redirects back to the client application with a code, and our application exchanges that code for a valid access token via the identity provider, and then we can access Graph API. Sounds horrible, but in the end, it's quite easy. So when using authorization code flows, we have some additional tokens we can acquire. So with a client credential flow, application permissions, the only thing we got was an access token, a time-limited access token. And as long as the access token is valid, we can access Graph API resources. Now, with the authorization code flow, we don't only get an access token, but in addition, depending on if we ask for it. So we have to tell the identity provider that we also want to have a so-called refresh token. And that refresh token allows us to get a new access token in case the access token is invalid or became invalid without needing the user. So very funny. So we can, so our application can act on behalf of that user permanently, as long as the application is able to use a refresh token to get a fresh access token from the identity provider. The access token itself contains information about, or limited information about the user. So typically only a unique identifier, a so-called subject, and some additional claims that may be roles or groups or whatever, but not any additional profile information like a phone number or the name and so forth. If we also need, besides the access token, the name of a user, the phone number of a user, and additional other claims, we can request an OpenID profile token. And this in turn gives us an additional token when we request the token using that code we got, with some additional information about the user itself. So with authorization code flow, you could get up to 3 different types of tokens: the access token for accessing resources, a refresh token for getting a fresh new valid access token without requiring the user to go through the authentication process again, and an optional OpenID profile token containing additional claims about the user itself. Now, there is a difference. So we can use Microsoft Entra for signing a user into the application. That's what we're doing today. So a user authenticates in with Microsoft Identity Provider and is then logged into the OutSystems application. That is essential to know. So the OutSystems user has in the end, or if you sign in to Microsoft Identity Provider, that does not automatically sign you into OutSystems. That's what you have to build on your own. So we will do that in a minute. And the other thing is to link an account. So the user is logging into OutSystems with regular email address and password. So just with the OutSystems user account. And then you link additional OAuth compatible identity provider authentications to that account. This part here is not covered today. I prepared a list of additional material where you can check out how to acquire and link multiple accounts to an OutSystems account for further reading, because that is quite complicated. Okay. Yeah. Enough of the theory. No, not yet enough of the theory. A little bit more theory before we start coding. If you want to do it on your own, you need access to your Azure tenant, which can be your company's tenant or a developer tenant, using the Azure portal. And you need at least to have the Cloud Application Administrator role to register an application, or you need someone else who has that role that registers your OutSystems application for you and grants you owner permissions on that registration. What we need to build is the first thing we have to deal with is when the user wants to sign in with his Microsoft account data, we need to construct a URL, which we use to redirect the browser of the client to that URL. So that is a so-called an authorization URL that contains some information we will see in a bit. Then we need to create a callback handler that is a screen or an exposed REST API, which gets the code of the successful authentication and then exchanges that code for an access token. Since, access tokens expire, and if you took part in the first webinar, when using client credentials, every time we were consuming a Graph API endpoint, we requested a new access token. That's okay for client credentials flow or for application permissions. Dealing with user permissions, it's good to store the access token we retrieved and reuse that access token until it gets invalid. Why is that? There is a high chance that your security department built some conditional access rules into Microsoft Entra, so that when you always request a new access token, it could be that you hit a limit and that your re-authentication gets denied. So it's good to store the access token and use it as long as possible, and then refresh the token if you acquired a refresh token on behalf of the user and store it again. So this is something we're going to build. And then last, we need to create a token handler, which returns a valid access token before we request a resource with Graph API. Sounds easy. And hopefully this turns out now and doesn't end in a disaster or in a huge troubleshooting session. Okay. These are just reminders for me so that I don't forget what to put in. So the authorization URL is something we retrieve from Azure App Registration. And It is constructed in that way that the client ID is appended as a query parameter. It has as response type a code. We define a redirect URL, which is a backlink to our callback page. Response mode, query. I will explain later on what this is all about. The scope, so what we are acquiring, well, we want to acquire the OpenID profile of the user. Offline access is a scope or is a permission which gives us a refresh token as well. And then some application-specific scopes delimited by a space about the permissions we want the user or the token to have to acquire or to request Graph API resources. And that state parameter, which we see in a bit, which is for ensuring or to validate that an authorization request really came from our application and was not hijacked by someone else. So the callback URL, which is a screen in our demo. So the callback page or the callback screen retrieves the code in case it was successful, authentication was successful. The state, which is a copy of the state we put into the authorization URL. And in case authentication was unsuccessful because the user canceled the authentication or could not log on for whatever reason, we retrieve an error and an error description we can use to tell the user what happened and why it happened. That is exchange code. That is the post request we need to initiate to the token endpoint of Microsoft Identity Provider using a form URL encoded post request, including the client ID, the scopes we requested, the code we retrieved from that callback. Once again, the redirect URL we put in here, and a grant type which tells identity provider, hey, we want to exchange now this code to an access token and potential some additional tokens, and a client secret we retrieved from the identity portal. And in case we want to refresh a token, we do the same to the token endpoint, but instead of transmitting the authorization code, we transmit the refresh token we got here with a grant type of refresh token, once again, the client secret. So basically, that's what it's all about to get an access token. And now it's time to build that all. Okay, so just let me share my desktop. So please remember that I don't see anything you're typing while I'm here. Okay, so let's start off. So we start off, what we need first is a registered application in the Azure portal. So we move to the Azure portal. Search for app registrations and create a new registration, what we call Graph API OutSystems webinar. We want to allow accounts from our organization to authenticate, and everything else we leave out for the moment. We just hit the register button, which immediately gives us a client ID. I'm copying this now, so the client ID. So that is what we need. We also need our tenant. So that is our Azure tenant. We need that ID as well. And the next thing we need is a client secret. And this can be configured under certificates and secrets. and we create a new client secret. Give it a description. That's the initial secret, so the secret expires. You shouldn't go for custom, but take the recommendation. So the secret is now valid for 180 days. Always remember that you will not get an automatic notification if the secret expires. You will note because people cannot log in anymore, but keep in mind that you do not automatically get a notification when this client secret expires. So we click Add, and we have to copy the value immediately because once we refresh that page, it will be hidden. So this is now our secret. I'm just refreshing the page here. And as you see, the value cannot be copied anymore. So the next part is that we have to decide what permissions do we allow the user to have that is configured under API permissions. And by default, the signed-in user has the right to read his own profile data, which we keep. But you can remove it, of course. And we add some additional permissions now. So we add a permission, click on Microsoft Graph. And the last time we were using this one, the application permissions. This time we go for delegated permissions. So we're acting on behalf of a user. And what we want to have when we request an access token, we also want to acquire the OpenID token. And we also want to get a refresh token. That is why we need at least those two scopes, OpenID and offline access. And then any additional permission in regards to Graph API, we want the user to do. So for example, okay, so I think it's called tasks. So we want also allow the user to create, read, update, delete user tasks and task lists. That is from the Microsoft To Do application. So we grant that right as well. Then we click Add Permissions. And this allows now a user to do everything what's inside that permissions once we acquired an access token for that user. So creating tasks and reading the personal profile data. Okay, so the last part we need to configure is that redirect URL, because we want the user to sign in, and then we need to retrieve the code which we exchange for an access token. And that is done here on the platform configurations. So we add a platform. In our case, it's a web application. And we need to enter the redirect URI, so the full redirect URI, which is, in my case, currently not existent. So we need to first create one. And just to let you know, I'm reusing the Graph Webinar application, which we built in part 1. So I'm extending that. And after this session, I will upload it or upload the new version to the Forge for you to download. So, but in our case, here we create a callback page. So a new screen, which we call callback. And that screen now, if if I publish that, that's the downside of doing something live. We always have to deal with that publishing time. Maybe I find some jokes I can tell while we are publishing. So let's see. So let's move to the callback page. So this is the full URI of our callback page, which may, of course, the callback page changes between your environments, but you can configure multiple redirect URIs here. So one for your development environment, one for your test environment, one for your production environment, or multiple environments. Okay, and we just configure that. And here you can, if you have a production environment and a test environment, you just add additional redirect URIs. So this tells the identity provider that it is only allowed to send the token to this page or to these pages, to these endpoints, and not to anything else. It's just for security reasons. Okay, so having all that, we can move forward. And the next thing, or the first thing we are doing is that we are constructing this authorization URL. So if you remember, and if you took part in the last session, I created a central core service module, which is called Entra Token Service. And we put everything in regards to exchanging information with identity, Microsoft Identity Provider in that Entra Token Service module. And I create a new folder, which I called Auth Code, and a first server action, which we get authorization URL. So that's the first thing we want to do. And this should return an URL. That's the only thing it should return. And if you remember from the presentation, that authorization URL, I quit PowerPoint, which was not the intended thing. Hold on. Okay, that authorization URL contains this state property. That is actually optional, but it is a good thing to include it. That is an arbitrary number you can use that you can check if, so you send that arbitrary string to the identity provider, and that string is included when the identity provider gives back the code to the callback page, which allows you to check if that callback really came from a request you initiated. So you initiate an authorization request, and then from the outside, so the identity provider comes back to your application, and then you get that state again and check, okay, was that really initiated by me? So from my application. So it's a good way to check if the authorization request was done by you. And how do we do that? So the first thing we want to do is that we create that state and store that state in a table or in an entity. So I'm creating a new entity, and I call this intent. And the only thing I do is that I change the identifier to a text file and give it a created on again. So so every time someone initiates a request, we want to create a new intent. So we create a new intent. and just with an ID of a generate GUID. So we're just using oh, I didn't have that. So we're generating a new global unique identifier, which we use as the state parameter. And then we are constructing our URL, our authorization URL. And that authorization URL can be retrieved in Azure AD from the endpoints button here. And this one, the authorization endpoint, that's the URL, or that's the base URL where we need to redirect the user to. So we copy this one. And we assign that URL to our output parameter. So potentially you don't, you would create a site property for that. And now we need to append those parameters. And those parameters can be found here. So we need the client ID. Plus, well, let's do that hard-coded for the moment. I guess you get the point by offloading this to site properties. So that's our client ID. And the response type, which is code. And the redirect URI, which is in my case callback. And the scope, OpenID, offline access. And if you remember from the first part, we need also provide the Graph API scope, which is graph.microsoft.com default. And our state. Which is the ID of our intent. Okay, so this gives us the authorization URL, which we try now to use in our client application. So what I did here in the web front end of the Graph Webinar sample, in the login page, I already created a button which is called Sign In with Microsoft. So, and as you see, nothing inside. And the first thing we want to do is that we retrieve now that authorization URL. And then we do a redirect. To that URL. So, okay, let's see if this is already working. Huh? Okay, sign in with Microsoft. Okay, so what's happening now? So we have that redirect URL on top. You see the client ID, the response type, the redirect URI. Please also note that OutSystems itself is encoding that string. So we have the scope or the scopes and that state we have here. And that one got appended by identity provider itself. Okay. And now, since I'm already logged in, so that account here, that Stefan.Weber at Spatium1, that is my default account on my workstation. So I'm already logged into the identity provider. So it's just asking me, okay, now that application is now requesting rights. And I have to give consent for that right. So the application asks for maintain access to data you have given it access to. So that's my user profile. That the application can, on behalf of my account, create, read, update, and delete tasks and task lists, and sign in and read your profile. So that is what I want to do, and I click accept. And then, hopefully, it should return me. Oh, you didn't see that because I didn't mark that as, I didn't mark it as anonymous, okay, which is bad. But in the end of the successful login, what I got now is a code, hopefully not an error message, and no error description. And that is the next part. So we configure now our callback page to get some input parameters. So that's foremost the code. And the code is only delivered when there is no error. So you want to set that as not being mandatory. So an error, again, the error is only sent when there is an error. The error description. And of course, the same goes here. And of course, the state. Okay. And let's now modify that callback page. So first of all, we're changing this to a blank screen. And remove the menu. So, and here what we want to do is that we just want to output our code. Our state, the error, and the error description, just for checking. Let's go here. Logging, sign in with Microsoft. Now this time you will note that I'm not asked for anything. So that is because I'm already signed in. So this is now a silent login. I've already gave consent, so there is no need to ask me if I give consent anymore because I already did for this application. And now returning to my callback page, I get that code. So this is the code. And this is the state. And as you see, we don't have an error or an error description. So that's why those fields are blank and not displayed. And so the next part is now that we take that code, so if we got a code, and exchange it for an access token. So once again, back in our Entra token service, we create a new, which we call process authorization. So authorization code, and it takes in the state, and it takes in the code. And here, the first thing we want to do is that we check if we have an intent in our database which matches the state. And if this is empty, we just raise an exception. Let's go with OAuth exception. And we just give back not a valid authentication request. But if we have a valid intent, so meaning if we are now sure that this authentication request or really came from our application, we now need to exchange that code for an access token. And just like the last time, you have two options to do that. What you can do is that you do it manually by posting to the token endpoint with the parameters we saw here. Okay. Or you can use the Forge component OAuth token exchange. We start with that. Okay. Let me know in the chat or in the Q&A if you want to see the manual approach. So because I'm using now this component, the authorization code token. So the token endpoint URL, that is from our endpoints here, this one. So the token endpoint. Our client ID. And our client secret. I hope you, if you joined part one, I was showing a way on how to securely store that client secret in a site property using Crypto API. It is strongly recommended to store that client secret in a secure way, whether it be encrypted as a site property or in an external system like AWS Secrets Manager, HashiCorp Vault, or any other password vault you may have. So then the code and the redirect URI. Let me copy that from the first one. And having this, that is what we, so this is where we get the access token. And let's see what we get when we come to this point where we exchange an access to an authorization code for an access token. So let's just add that here. So in our callback page, we add an onReady. So when we're ready, this is what we do. We take the state, we take the code. Let's publish that. Now let's go here and add a breakpoint so that we see what we get from that authorization code exchange. Oh, makes me totally nervous, huh? Because hopefully this works now. Okay, let's see. So being here again, sign in with Microsoft. And now we're here, and let's see if this is working. If success is true, that is good. So what we got now is we got an access token type bearer that expires in 4,820 seconds that is configured at the identity provider. A refresh token, identity token, and all the scopes we can use, which is more or less just for informational purposes. And that access token, that is a base 64 encoded string. You can copy that, and then you can look what's inside that token using JWTIO. And you just copy it here to the encoded string. And then you see, an access token that is divided by dots. So it has three base 64 encoded strings. One is the header information about the algorithm and signature and whatever. Then the actual payload. And the payload contains lots of information. So for example, the app display name, the app ID. It also includes my family name and given name. Okay, but that may not be the case in your situation. And what's very important here is it also contains where is it? A subject. And the subject is a unique identifier representing your user. And that user is unusable for your case because most likely you don't have that subject stored in your users table. So for example, in the external ID anymore, but what you have is the UPN. So this is the UPN, which is in most cases the email address, and you would use that email address to find a valid OutSystems user. So because that is what we have to do next. So this is a little bit more tricky. So what we need to do to get, because we need to know what user is it, what is the user? and we're using the UPN name as an identification to query our users table in OutSystems to find a user that has an email address that corresponds with that UPN. And if we found that user, we log the user in. So as easy it is. And in order to do so, we have to do two things. We have to split this access token into 3 parts so that we get that payload part. And we have then to convert that base 64 encoded string into text. And then we need to deserialize that text into a JSON structure. Okay, let's do it. Okay, so the first thing we want to do when processing is if we received an access token, then we go ahead. If not, we just simply raise an exception. I could not retrieve access token. But if we have one, we split. Oh, I should have done that before. We split that access token. So the access token by dot. And then we do some conversions. So we do from the binary data extension, first we need to convert, because the binary data extension does not directly convert from base 64 to string. We first convert to binary. And then from binary to text. This one, which is now from string split list, the first element, the text, the value, and then to text. Okay. So now we have the text, and now we need a very small structure we call access token parse, I don't know, where we add the UPN, which is this one here. So this is our payload, and one of the properties is the UPN, and we only need that UPN for the moment. Okay, and then we deserialize that text to our structure. Then we look up our users table. If we have a matching user, that is active and the email address is our deserialized UPN. And if we don't have one, then we raise an exception. Cannot find OutSystems user. But if we have one, we can now log in that user. And there is one system user action where you can, oh, so many with login, where you can log in a user without password. So we have that user login from the users module, but this requires you to have a username and a password. In our case, we don't have a password at the moment. We just want the user to sign in. But there is another one. It's just called login from the system module, where you can log in a user just by its ID. So we say login, which is the found user ID, and we say persistent is false. So we don't want that user to be persistent, and you will immediately get a warning telling you that please consider login actions from the module users, but we don't have a password. So we can't do that. Okay, so this is now our server action for getting an access token, deserializing the token, logging on as a user. So once that successfully went through, we can redirect the user back to a page, to a screen that is protected, so that is not anonymous. And we just published that. Oh, I have the debugger running. But I just want to show you how this is working. Just give me a bit. As said in the previous webinar, it is a good idea to wrap those server actions into service actions to have a loosely coupled service for dealing with all that authorization stuff here. Okay, so let's debug that again. Going back to our application. Okay, sign in with Microsoft. We're now here. So once again, we get that access token. It was successful. We split that access token, which gives us 3 parts now, starting with a 0 index. So this is the header, this is the payload, this is the signature. We first convert it to binary. Now, what did I do now? Okay, something new. That is what I meant with that ad hoc thing. So let me check. Let me check again. So what is inside? But I have an alternative, so no worries. We already used that. I hope you're all smiling, seeing someone else troubleshooting. Yeah. And this is, it doesn't like me. Okay, so, but no worry, that there is always an alternative we can use. And in order to speed that up, what we can use is another Forge component that is called JVT. Maybe I should have shown that before. But JVT is a component which does that part what I'm obviously just tried to do completely. So you have that read token without validation action. So JWT is from the Forge, right? Okay. So we're using this. We read the token. So we don't need to split it now. Oh. Okay. We have the encoded token, which is the access token. And this returns now that subject and lots of other things. But let's see what it returns. Just disable these elements. So, and this one should now return So this is what it returns, including those custom claims, which are in somewhere here inside is a custom claim that is called UPN. So we go ahead and apply a filter here. Oh, nothing included. So we filter the custom claims with a condition of name is UPN. Okay. And then we can go ahead. So we just assume now that we always have that UPN claim. But in reality, it's good to do some further checking. But in our case, we just go ahead and use this one now as a filter. Which is then the value of the current element. Which should give us now a successful login. So let's see. No. Oops, that's not what I wanted to do. So we read the token. We filter by the UPN, which should give us now in the current element my email address. We look up the users table if we have a user with that email address, which should give us one element. So that should be me. Perfect. And that is why we can now log in to the system using my account. So if I go back now to the start page, I'm logged in with my user account. But that was only the first part because we need to store that access token now. So in that case, we go ahead and create another table, which we call token cache. And each user can have exactly one access token. And we store the access token and the refresh token. Oops. And the expiry, access token expires on, and refresh token expires on. Okay. So after we successfully logged in, we now have access to the get user ID function, which is good. And now we store everything we retrieved from our identity provider in our token cache. So we use that create or update token cache for the current user ID. The access token, the refresh token, and this one. And there is, what I didn't explain is that sometimes sometimes you will not get an expiry date for a refresh token. That depends on the identity provider if it returns an expiration date from a refresh token. If there is no expiration date time for a refresh token, that means that the refresh token is permanent. So you can use it anytime. So it does not expire, but every time you use a refresh token, you will get a new refresh token from the identity provider. Okay, so let's just skip that out. So this is where we store now our token for the current user or for the logged in user in a token cache. Okay, so let's try it out. We just modify our process authorization code flow, and we're just giving the destination to our main screen. Publish it. Let's see, let me log off again. So we sign in with Microsoft. Magically, something happens, and then we're here, fully signed in. And if everything went right, we now have an entry in our token cache. Yeah, with our access token. Okay, so that was the complicated part. Now comes the more easier part. Huh? So what we want to do is, now that we use that access token to use Graph API. So we need a third action, what we call get access token. Okay? And we want to get the access token for a specific user ID. And it should return a user identifier. And it should return the access token, which is just text. Okay, in that case, we go ahead and see if we have in the token cache, if we have a token. For the user ID here. If not, so if that is empty, the user never authenticated with identity. So we just throw an exception. So typically you want to do some other type of error handling and not just throwing exceptions, but no access token available. And the next thing is if the retrieved access token, if the expiry expires on is smaller than the current date time. So if it expired, So here we go to refreshing a token. Okay, so but for now we just end out. So if it's not expired, then we return the access token. Okay. Okay, let's publish that. And while that is publishing, let's look now on what we want to do is, so we want to use, or we want now to retrieve the user profile from that user. And in order to do so, we can go for, or we can use that Graph Explorer, which is good to find out what we need to do. So to get my profile, I need to initiate a GET request to graph.microsoft.com v1me, that is for me. And in order to try that out with my very own tenant, I can directly log in here. So I can log in with my credentials. And then it switches the tenant to my tenant. And if I run that query now, okay, so I get some information back. So in that case, the system was, or Graph Explorer was using this access token. So that is a valid access token. It retrieved when I was logging on, and I can copy that. And if I go back to OutSystems, I can now go ahead and see. I can now create a new module, which I call Graph My Profile. I go to REST and say I want to consume a REST API with a single method to, it's a little bit smaller, to https graph microsoft.com v1.0 me. And what I can do now is I copied that access token. I can go to the header and authentication, add an authorization header, click on test, type the word bearer, followed by a space, followed by my access token I retrieved from Graph Explorer. Click on test. I got an OK back along with my data. I copy this to the response body and then click finish. Okay, so get profile, okay, which delivers a response. Of course, you can modify the structure to only include things you want to have. For example, you don't need that OData context. So you can just go ahead and remove that. We don't need that. ID is good. Okay, then we create a wrapping server action, which is graph get my profile that takes in an access token and that returns something, a result. So in that case, we're calling the get profile. We add that bearer plus the access token. And then we create a result structure. Let's call this profile result. And we want to have the display name, this one, surname, and the ID. Add that here to the result. Sign it. In the response, set this to public. And now in our application, what we create is a profile page. And in that profile page, we now want to fetch our profile. And in order to fetch it, we first have to get the token and use that token to query Graph API. So first thing is to set the get access token to public. And then we can get the access token here. For the current user ID. Okay. We assume now that this is all working, of course, which it will never do in production, of course. And then we can query from our integration service the graph get my profile. Using the retrieved access token. and we set the result here to the profile result structure. And now we're good to go. Let's say we do an expression here. Hello. I just append the display name. That should be enough. Okay, let's see if it works. I mean, it should work. So once again, I log out. I sign in with my Microsoft credentials. Get redirected here. Oh, missed to add it to the menu. But I know it's called profile, right? And this is, okay, hello, Stefan Weber. This comes now from the service. So if we debug that here, okay, we see that our action received now an access token. Then it queries the Graph API via the REST interface and returns the result. Okay. And in our application, or in our token service, we were using this get access token at a breakpoint here. Oh no. No. Okay. It looks up the token cache. Obviously, it found something because empty is false. It checks if it is expired. It's not yet expired. And then returns the access token, okay, to query Graph API. So as you see, Graph API itself is quite simple, but getting a token, that is the challenging part of it. And for the last part, if now this one is expired, so if the access token is expired, what we do is that we simply go ahead and use our helper action here from the OAuth token exchange, which is called refresh token. So we refresh the token. Copy everything over. That is why you should do it in a site property. The secret. and the current refresh token. Oops, I have to move this a little bit up. So now the refresh token. And if that succeeds, okay, so if this here is a success, then we just update our token cache for the user. We got a new access token. Potentially, we got a new refresh token, and of course, a new expire zone. Okay, and if we couldn't refresh, once again, we just throw an exception. And that's the magic. Of course, in regards to all parameters, you just put it into site properties, except the client secret. So here you definitely want to make sure that it is encrypted. Review the first part of this webinar to see how you can encrypt site properties using your platform private key, or offload the client secret to an external system like AWS Secrets Manager, HashiCorp Vault, or many of the others available products. Okay. And that's it for this webinar, basically. So we saw how to acquire an access token using Authorization Code Flow and use that token to query Graph API resources. So, and always good to check with Graph Explorer because you already have an access token. You can try out many of the available REST API endpoints, then copy over the access token, copy over the request body, for example, for tasks. Let me see, it's called to do. How's it called? Always the same, to do. Okay, here it is. So if you want to create a task, you can just copy the request body, but always think of what you get in Graph Explorer is not the full range of properties you can put into a post request. So it's always good to check out the documentation. You will find a link to Graph API documentation also in the presentation. To get all that additional properties. You copy it over to your REST consume and let OutSystems generate the request and response structures on its own. So really nice to do. Okay, so one thing back before I go over to the Q&A is, let me share back the presentation. So that's what we implemented so far. And everything, I was talking about, you will find additional links in that additional material slide, and also 2 articles I wrote for acquiring and linking multiple OAuth tokens. That is actually a much more, let's call it, a much more mature sample for how to deal with token caching, token refresh, and so forth. And if you know what we built now from scratch using nothing but our hands, basically, there is also a component available on the Forge, which is called Microsoft Logging Connector or Reactive Logging Connector. Very good made. Basically, what the creator did is what we did now on our own. he created a reusable component for it available on the Forge, and how to use that you will find in the Getting Started article I wrote here. Okay, and let's see. Now I click on that Q&A button. Oh, okay. Let's see, Q&A. It's loading. Okay, so nothing in the Q&A section, but we have something in the chat. Yeah, let's see. No, we have. Oh, we only have one question by Joao. I hope I spelled that correctly. Will this session be available later? Yes, it will be available later because he stepped out, right? Okay. It will. So yeah, that's it for today. Thank you very much. Okay, so I'm not sure if I will do that in the same or doing the same from scratch the next time as well. That live coding is a little bit challenging. So potentially next time I will prepare some stuff up front again. And what's coming up? So now that you know how to acquire credentials with using an application or credentials using a user, and how to use that Graph API endpoints, which is actually very simple, then you're ready for subscribing to events. So that is, you want to trigger your application every time something happens in Graph API. For example, you want to react on inbound emails, or when someone creates a contact, when someone creates a new Outlook group or whatever. So in that case, you can subscribe to such Microsoft Graph API events and then do whatever you want to do in your application. And that's what we're talking about in January. So hopefully in January. So how to subscribe to those events, how to consume those triggered events in OutSystems. So it's a webhook. How to consume that webhook, and how to deal with subscription authorization, specifically on how to iteratively refresh that subscription authorization. Okay, then thank you very much. It was fun, it was challenging, but fun. And hope to see you next time. Thank you very much. Bye-bye.